Welcome to the talk team. Not sure. Now we're looking at the Raphson method there. Perform 4 iterations of the Raphson method to find the smallest positive root of the equation a of x equals to x cubed minus 5x plus 1 equals 0. Now we define the root of this equation. Now it is believed that a root exists between two given points if the signs of the values of this function are different. So first of all, we have to try to select different points and check the value of these functions, whether they have different signs. Number one, if you decide to pick 0 and 1 as values of x, we consider x as 0 first. We take x as 0 and x as 1. When x is 0, this is our function f of x equals to x cubed minus 5x plus 1 equals 0. And in Raphson, we need f prime of x, which is rejecting 3 to x to the power of 3, you have 3x squared minus 5. Now, if you take x as 0, f of 0 will give us 0 to the power of 3 minus 5 into 0 plus 1. Now, 0 to the power of 3 is 0, 5 times 0 is 0, plus 1 will give us 1. Now, if you take x as 1, f of 1 will give us 1 raised to the power of 3 minus 5 into 1 plus 1. Now, 1 to the power of 3 is 1, 1 plus 1 is 2, 2 minus 5 is minus 3. Now, you notice that f of 0 is 1 and f of 1 is minus 3. Now, there's a change in sign for these values. Here is plus, here is minus. Now, whenever you have two values, two values of x, and the corresponding value f of x changes sign, it means that the root exists between those points. But then, we can have between 0 and 1 is one of the intervals for which the root exists. We can also check for other intervals, which we will look at subsequently after using the Raphson method. Now we can start our initial approximation by saying 0 plus 1 divided by 2. So our initial x can be 0 plus 1 divided by 2, which is as half. So we go to the Raphson method, which says that xn plus 1 is equal to xn minus f of xn divided by f prime of xn, where n is 0, 1, and so on, continuous. Now, understand that if you observe, everything about our right hand side is xn. So even if you remove the subscript and work with x, it's the same thing. Having in mind that when you finish, to avoid much complication, you can always return back your n. See, everything here is about xn. So we replace our f of x and by x cubed minus 5x plus 1, we have this, divided by f prime of xn, which is 3x squared minus 5. Now, if you take the LCM of these two, you have 3x squared minus 5, which is this. Now, this same thing as this divided by 1. So that if you take the LCM, this divided by 1 is 70. Multiplied by x, we have this x into 3x squared minus 5. Minus 3x squared minus 5 divided by 3x squared minus 5 will give us 1. 1 times x cubed minus 5x plus 1. You have this. So if we expand, we have x times 3x squared minus 5, which is 3x cubed minus 5x. Now, if minus open, we have minus x cubed plus 5x minus 1 divided by 3x squared minus 5. Now we have 2xn raised to the power of 3 by replacing x by xn, which was given initially. 2xn raised to the power of 3 minus 1 divided by 3xn squared minus 5. So n still remains with 0, 1, 2, so on. This gives an expression for obtaining the root of this given equation using the Raphson method. Now, I said earlier, you have x equals to 0.5. So if you replace our x over 0.5, now when n is 0, we have 2x cubed 0 minus 1 over 3x squared 0 minus 5. Now, when n is 1, now we will replace x n by 1. We have n2 give us 2x cubed 1 minus 1 divided by 3x squared 1 minus 5. So we proceed to find the root of the question, which is this. Now, first of all, replace our x2 by 0.5. 2 into 0.5 is the power of 3 minus 1 divided by 3 into 0.5 is the power of 2 minus 5. Now, 0.5 is the power of 3 times 2 gives us 0.25 minus 1 divided by 0.5 to the power of 2 times 2 gives us 0.75 minus 5. Now 0.25 minus 1 divided by 0.75 minus 5 gives us 0.1765. That's our initial first expression. We go to the second one, we have x2. Remember I said when you have n by 1, if move from n already, move to 1. Now when you replace n by 1, you have 1 plus 1 is 2. So you have x2 will give us 2x cubed 1 here, which is here, minus 1 divided by 3x squared 1 minus 5. Now the first value we had was expression was 0.1765. So you replace your x1 raised to the power of 3, x1 by 0.1765 all to the power of 3 minus 1 divided by 3 into 0.1765 raised to the power of 2 minus 5. Now, if I evaluate this, solve this, I take the cube of this, multiply by 2 minus 1 divided by square of this value, that is 0.1765 raised to the power of 2 times 3 minus 5. You have 0.2016. That was second iteration. Now, for the third one, we have x cubed. Remember, in this case, n is 2. We have x3 is equal to 2x to the power of 3 minus 1 divided by 3x2 raised to the power of 2 minus 5. Now, our initial value was, our second iteration is 0.2016. So you have 2 into 0.2016 raised to the power of 3 minus 1 divided by 3 into 0.2016 raised to the power of 2 minus 5. Now, if you calculate this, you still arrive at 0.2016. Now, we can now proceed to the fourth iteration. For the fourth iteration, x4, in this case, n is 3. So for iteration, you have x is equals to 2x to the power of 3 minus 1 divided by 3 x squared 3 minus 5 is equals to, we replace our x3 by this, raised to the power of 3 minus 1 divided by 3 into 0.2016 to the power of 2 minus 5. The result will be the same as this, since this and this are the same. So you have 0.2016. Now that's our fourth iteration. That means that the root of this equation is 0.2016. Now also, if you also wanted to check for other intervals possible, we have looked at f of 2. For f of 2, replace x by 2. We have 2 to the power of 3 minus 5 into 2 plus 1. Now 2 cubed is 8. 5 times 2 is 10. 8 minus 10 is minus 2. Minus 2 plus 1 is minus 1. Now for f of 3, 3 to the power of 3 minus 5 into 3 plus 1. Now 3 to the power of 3 is 27. 27 minus 15 is 12. 12 plus 1 is 13. Now the sign has changed from minus to positive. It means that there's a root between these two values, between 2 and 3. Now for the third case, since you have a cube, the power of x is cubed here, that means you have 3 possible roots. So the next one, f of minus 2 will be minus 2 to the power of 3 minus 5 into minus 2 plus 1. Now minus 2 to the power of 3 is minus 8. Minus 5 into minus 2 is 10. 10 minus 8 is 2. 2 plus 1 is 3. Now f of minus 2 will give us minus 2 to the power of 3. That's replacing x here by minus 3. You have minus 2 to the power of 3 minus 5 into minus 3 plus 1. Now, minus 2 to the power of 3 is minus 27. Minus 27 plus 15 is minus 12. Minus 12 plus 1 is minus 11. So, there's a root between 3 and minus 11. But since we're looking for the smallest positive root, that is x equals 0.2016. Thank you viewers all over the world for watching. Do it, just share, like, subscribe, comment. If you have questions, drop at the comment section. Thank you.